Okay, now it lets me leave a marker. Okay, let's... It's being weird. Alright, let's get back to it. This... Stream's being weird today. Okay, so, getters. Getters are methods that get and return the internal properties of an object, but they can do more than just retrieve the value of a property. Let's take a look at a getter method. So, get full name, and if first name and last name is available, we return first name and last name. Okay, so getters are essentially just methods that retrieve data from within the object, is what I'm getting. Get it? Getting. And I assume setters are simply methods that will change the properties. So we use the get keyword followed by function. If we use if-else conditional to check if both first name and last name exist by making sure they both return true the values and then return a different value depending on the result. We can access the calling object's internal properties using this. In full name, we're accessing both this first name and this last name. In the last line, we call full name on person. In general, getter methods do not need to be called with a set of parentheses. Syntactically, it looks like we're accessing a property. Oh! So it's just a sneaky method. Okay. So now that we've gone over the syntax, let's discuss some notable advantages of using getter methods. So getters can perform an action on the data when getting a property. Getters can return different values using conditionals. Conditionals, right. In a getter, we can access the properties of the calling object using this. And the functionality of our code is easier for other developers to understand. Right. So another thing to keep in mind when using getters and setter methods is that properties cannot share the same name as the getter-setter function. If we do so, then calling the method will result in an infinite call stack error. One workaround is to add an underscore before the property name, like we did in the example above. Okay. Wait, what? Is that properties cannot share the same name as the getter-setter function. Oh, you mean these and these? Okay. Okay, so in robot, create a getter method named energy level using the get keyword. All right, so get energy level. Wait, no. Like so and like so. Get energy level like so. And inside it, add an if statement to check if this energy level is a number using the type of operator. Okay, so if this energy level. Wait, no. Level. Level. Oh, we're supposed to do... Let's take a look at the type of method. How does it work? Again, type of blubber, type of 42. Oh, so if type of this dot energy level equals number, like so. Return my current energy level is just this energy level. Correct? Correct. Make sure you return the string instead of logging it to the console. Yes. So otherwise, it could be the energy level property was altered. Let's add a return statement for when such a scenario arises. Add an else statement, else, that returns system malfunction, cannot retrieve energy level. Right. So now we just log the result of calling the getter method energy level. So console log robot dot get oh no, we don't have to write get here. We just write energy level. Yes. Okay. I get it. Wait, it seems my stream has cut off for some reason. Yeah, it stopped. For whatever reason. 13 minutes ago. This bizarre behavior from Twitch. Okay, well, it happened. Can't do much about it. All right, let's move on. Setters. Along with getter methods, we can also create setter methods, which reassign values of existing properties within an object. So set age, type if, type of new age equals number, this age equals new age. Okay, so we can perform a check for what value is being inserted into this age. We can then use a setter method. When we use a setter method, only values that are numbers will reassign this age. And there are different outputs depending on what values are used to reassign this value. Okay, so then to use it, we simply use it like so. Wait, what? With the equal sign? And not just as a function? Okay, setter methods like age do not need to be called with a set of parentheses. Syntactically, it looks like we're reassigning the value of a property. Like getter methods, there are similar advantages to using setter methods that include checking input, performing actions on properties, and displaying a clear intention for how the object is supposed to be used. Nonetheless, even with a setter method, it is still possible to directly reassign properties. For example, in the example above, we can still set the age directly. Okay, so currently in Robot, there is a getter method for number of sensors, but no setter method. What if we need to add or remove some sensors? Let's fix that problem. Add a setter method named number of sensors using the set keyword. Provide a parameter of num and leave the function body empty for now. Okay, so set num of sensors a set. Oh, we have to pass it num parameter. Yes, because then we have to access it. There are a couple of things we should do in the setter method. Add a check to see if num is a number using the type of operator. So same as before, type of this dot of num equals number. And is greater or equal to 0. Then we reassign this dot num of sensors equals num. No. Unexpected token. Oh, right. And num. did you use an if statement to check if the argument passed to this dot number of sensors is a number greater than or equal to 0? I did. Do we need like separate parentheses for these? No, something Codecademy related probably. No, it's exactly the same. But okay, the extra parentheses are not needed. If type of num equals number and number is greater or equal to 0, this dot num of sensors equals num. It's exactly the same. Find three differences. This dot num of sensors. Wait. Ah, there we go. Sensors. Okay. Now add an else that logs pass any number that is greater than or equal to 0. Okay. Pass in a number that is greater than or equal to 0. And now we can use the num of sensors setter method on robot to assign. But does it actually? Well, I guess it does, because we're passing a variable into it. So robot dot num of sensors equals 100. And to check if it worked, we can console log robot.num of sensors 100. Okay. So it works. Factory functions. So far, we've been creating objects individually, but there are times where we want to create many instances of an object quickly. Here's where the factory functions come in. A real-world factory manufactures multiple copies of an item quickly and on a massive scale. A factory function is a function that returns an object and can also be reused to make multiple object instances. Factory functions can also have parameters, allowing us to customize the object that gets returned. Let's say we wanted to create an object to represent monsters in JavaScript. There are many different types of monsters, and we could go about making each monster individually. But we also use a factory function to make our lives easier. To achieve this diabolical plan of creating multiple monster objects, we can use a factory function that has parameters. So, right, function, parameters like name, age, energy source, and catchphrase. And then we return those parameters. Okay, this is a little bit more reminiscent of classes, because we're reinitializing the same things. Okay, in the monster factory function above, has 4 parameters and returns an object that has the properties name, age. Okay, so parentheses return objects, or curly braces return objects. So to make an object that represents a specific monster like a ghost, we can call monster factory with the necessary arguments and assign the return value to a variable. Right. With monster factory in place, we don't have to create an object literal every time we need to get a new monster. Instead, we can invoke the monster factory function with the necessary arguments to take over the world or make monsters for us. Okay, so instead of making individual robots like we've been doing, let's make a factory function to make robots as we please. Okay, so to create a factory function, robot function, we go const robot factory, and we pass in arguments like model and mobile. Oh, getting text messages from someone. Let's take a look. Gonna get a delivery, though not sure what time. Also, 1 second, I have to put my phone to charge. He's such a sleepy little boy. Alright, so when we left off, we were creating a robot factory. Model and mobile. Make the function return an object. In the object, add a key of model with the value of the model parameter. And add another property that has a key of mobile with a value of the mobile parameter. All right, so return, return and we return what? We return model with the model number, let's say. Oh, no, we just return model, like so. And then, wait, let's do it a bit better. Model, model, and mobile, mobile. And then we also need a method named beep. Wait, how do we write methods again? Oh, it's just parentheses, and then we have to console log beep boop beep boop. Oh, missing initializer in const declaration. Excuse me, what? Oh, the equal sign is missing. Unexpected token. Let's see. That's fine, that's fine. It should be working. I guess we need the arrow. That's the problem. Yeah. Okay, it's still a little bit confusing when we are adding arrows and when we're not. Because technically, this is not an object. Oh, well, it's not an object. It's a function that returns an object. Okay, then it kind of makes sense. Okay, use your factory functions by declaring a const variable named tin can. Okay. Tin can. Assign to tin can the value of calling robot factory with the first argument of p500 and the second argument of true. So tin can equals robot factory p500 and true. All right. Now let's check what tin can do. So tin can dot beep and beep boop. Okay, so now if we wanted to create another object, let's say world destroyer robot factory destroyer and true. And we can do the same with world destroyer equals or dot beep. Right. Okay. The only downside I see now is that we cannot change the methods inside. Like every single object created with this function will only output identical methods. Like we can pass in, or I guess we could do message and message. Message and just do, instead of that, we can do this. Right? Actually, should be this dot message, I think. So now we can actually pass in a message. I am a trash can, and all your worlds belong to us. Aha, no. Interesting. Maybe we don't need this. Yeah. Alright, because we don't need this because we're just passing in like normally. This is not within an object itself. This is just instantiating an object. Okay. That makes sense. Let's continue. So property value shorthand. ES6 introduced some new shortcuts for assigning properties to variables known as destructuring. In the previous exercise, we created a factory function that helped us create objects. We had to assign each value property. We had to assign each property a key and value, even though the key name was the same as the parameter name we assigned to it. Right. To remind ourselves, here's a truncated version of the factory function. Yes, I recall. So imagine if we had to include more properties. The process would quickly become tedious, but we can use a destructuring technique called property value shorthand to save ourselves some keystrokes. The examples below works exactly like the example above. Oh, so we don't have to add this part. We just type them out. Notice that we don't have to repeat ourselves for property assignments. Yeah. So use property value shorthand and refactor the factory function in main.js. So that just becomes this and this, correct? Correct. Oh my god, hiccups. Okay, let's continue. Destructured assignment. We often want to extract key value pairs from objects and save them as variables. Take, for example, the following object. So if we wanted to extract the residence property as a variable, we could use the following code. Right, just residence and residence. However, we can also take advantage of a destructuring technique called destructured assignment to save ourselves some keystrokes. In the destructured assignment, we create a variable with the name of an object's key that is wrapped in curly braces and assigned to it the object. In the structured assignment, we create a variable with the name of an object's key. Well, you're actually creating a variable with the name of the object's property. I guess it's the same thing. Object's key, object's property. And assign to it the object itself. Okay, this is a little bit confusing and seems unnecessary. But, okay, when we look back at the vampire object's properties in the first code example. Then in the example above, we declare a new variable residence that extracts the value of the name of the residence property of vampire. When we log the value of residence to the console, Transylvania is printed. We can even use the structured assignment to grab nested properties of an object. Okay. Vampire preference, day. Okay, it's just a little bit of a backwards way of reaching the values of properties. All right, let's use a destructured assignment to create a const variable named functionality and assign it a property of robot. Oh, assign it the functionality property of robot. So just robot. Yes. Since functionality is referencing robot functionality, we can call the methods available to robot functionality simply through functionality. And call the beep method. So functionality dot beep. Yeah. Okay. Makes sense. Take some practice to understand, to remember it probably, but it's all good. So in the previous exercises, we've been creating instances of objects that have their own methods, but we can also take advantage of built-in methods for objects. For example, we have access to objects instance methods like as own property, value of, and many more. Practice your documentation reading skills and check out MDN's object instance documentation. Sure, let's take a look. So we have value of, toString, toLocale define getter, define setter, lookup getter, lookup setter are depreciated and should not be used. We have static alternatives, define property and get own property descriptor. Interesting. The proto property is depreciated and should not be used. The get property type of, prototype of, and set prototype of. Property is enumerable and has own property methods can be replaced with get own property descriptor and has own static methods respectively. Okay, this is a lot of information that I probably don't need at the moment. So let's take a look at what do we have to do. In the main.js, there's an object robot. We'd like to grab the property names, otherwise known as keys, and save the keys in an array, which is assigned to robot keys. However, there is something missing in the method call. Find out what we have to include by reading object keys documentation. Okay. We'd like to grab the property names of robot. So model, mobile, sentient, armor, and energy level. Okay. And the keys method, how does that function? We have an object. Oh, we just type in the object name. So we just type in robot. No. Robot entries is not defined. Robot entries? Keys, object 1. Object 1. This should work. What am I missing? It did grab the properties, but robot entries is not defined. Oh, it's complaining about this. Okay, never mind. So robot entries will also return an array, but the array will contain more arrays that have both the keys and value of the properties in an object. Declare a const variable, robot entries, and assign it to the entries of robot. By calling object dot entries robot, like so. Yes. What does the entries do? Entries. Static method returns an array of a given object's own enumerable string keyed property key value pairs. Oh, so entries will return key value pairs, whereas in just keys will return just the keys. All right. So what if we want another object that has the property of robot, but with a few additional properties? Object assign sounds like a great method to use, but like the previous example, we should check the documentation. So we have static method copies all enumerable own properties from one or more source objects to a target object. It returns the modified target object. So this is our target object with A property of 1 and B property of 2. And this is our source. What if we want another object that has the property as a robot, but with a few additional properties? Okay. So we create a new variable called new robot. Will be a new object that has all the properties of robot and the properties in the following subject. In the following object: laser blaster and voice recognition. Okay, so we just define a new object with new properties like laser blaster, and voice recognition. Right. And then we just use the assign method. I think. Oh, we don't really need to do that. We can simply say here object dot assign, and we will put everything inside here. Like so. And that technically should work. No. Object assign is not a function. Oh, misspelled. Huh. So we printed out the new robot. Maybe we can't do it that way. So this will create new robot object with these additional properties. And then we can say new robot will be a new object that has all the properties of robot and the properties in the following object. Okay, so, right. Let's do new properties instead. And then we can have the assign object or the new robot object equals object dot assign, and this is the target and source. So our target is the new properties, and our source is just robot. No. Wait, let's comment out these. I want to see exactly what is being printed out. Again. Wait, no, we're adding new properties. So what's the problem? I mean, it works, but it's probably Codecademy solution is a little bit different. Oh, we have to do it the other way around. No, it's fine. It's just okay, they don't like that I used a different thing for that. Sure. Let's do it that way. Const equals const new robot equals object assign, and then we can just assign the properties of laser blaster crew and voice recognition as crew and then robot. Yeah. So it's the output, it was the same, except Codecademy didn't like my phrasing. So we still get them added to the front of the object. Okay. I get it. Congratulations on finishing advanced objects. Let's review the concepts covered in this lesson. So the object is The object that a method belongs to is called the calling object. This keyword refers to the calling object and can be used to access properties of the calling object. Methods do not automatically have access to their internal properties of the calling object. The value of this depends on where this is being accessed from. We cannot use arrow functions as methods if we want to access other internal properties. JavaScript objects do not have built-in privacy, rather there are conventions to follow to notify other developers about the intent of the code. The usage of an underscore before a property name means that the original developer did not intend for that property to be directly changed. Setters and getters. Setter and getter methods allow for more detailed ways of accessing and assigning properties. Factory functions allow us to create object instances quickly and repeatedly. And there are different ways to use object destructuring. One way is the property value shorthand, and the other one is destructured assignment. As with any concept, it is a good skill to learn how to use the documentation with objects. Okay. We've already done all of these, so we'll just continue on to probably a quiz. Yes. All right. So which of the following is an example of destructured assignment? Let's take a look. It is this one. Yes. You can use the syntax to create a variable name with a value of my dog's name property. What will the following code output? So we're logging key or key in car. So we will be logging numDoors is dirty and colors or color. Which of the following statements is correct? Objects only store strings. No. Objects can't store other objects. Wrong. Objects store unordered data of any data type as key value pairs. Likely correct. And objects store data in numbered positions. So this one. Yep. What should we add to the empty with discount method to return the cost of the meatballs object with a $2 discount? Okay, so with discount method, cost is 5, so return this cost minus 2. Correct? Correct. Okay, which is the correct syntax for creating an object literal? I still need to brush up on my definitions. Specifically, what is an object literal? Is that a property, just a property? If so, then this is the correct way. Yes. What are the keys in this object? Coffee maker, ceiling fan, and books. Yes. What is a factory function? A function that returns an array of objects a function that takes an object as an argument and then modifies it, a function that returns an object. It is a function that returns an object. What is a method? A method is a general term used to describe how to create objects. No. A method is a property with a function as its value. No. A method is a function that takes an object as its parameter. I guess is this one. It's a property with a function as its value. Yeah, makes the most sense. Given the following code, which expression will evaluate to apples? So our apples are stored in the refrigerator produce drawer root 0. So it's this one because multiple word properties are accessed using square brackets. And then dot fruit and 0. Yes. What's wrong with the setter method in the example below? Okay, let's try to remember the setter methods. Set num in and num equals num in. So this is fine, and this I don't think there's anything wrong with this method. Because let's think about it. We are setting a parameter, and then we are appropriately using the set keyword and defining a function essentially with a parameter num in, name of which can be whatever we want. And then we are accessing the variable. Wait a sec. Yes, this probably should be this .num because we don't inherently have access to the object's properties from within functions. Yes. All right, how can we add a property to the object below? So we want to add property specialized. Equals red. This I do not know. Look at how the dog sleeps. He literally has all of his feet on the wall. And specifically on the wall that I've repainted like a week ago. Ugh. Okay. bikes equal specialized red. Bikes dot specialized equal red. I think it's this one, because if I remember correctly, if we are trying to access a property or assign a value to a property, if the property exists, then the value will be changed. But if it doesn't, it will be created. So I think it's this one. No. This one. When using dot notation, we don't put... Oh, right. Okay. That's my bad. Right, which of the following object methods can be used to copy all of the properties of an object into a new object? It's assign. What are the keys? Coffee maker, ceiling fan, and books. What is a method? Method is a property with a function as its value. What will the following code output? It will output num doors is dirty color. How can we call the method in the code below? MyObject.sayHello. Yes. Which of the following statements is correct? Yes, this one. Right, which of the following is an example of destructured assignment? It is this. Which line of code would not print the value saved to the num key in the temp object? Would not do it. So console log temp object dot num. This will print it. Because we're returning this. Then temp object dot num. I think this one won't print it because it's a getter method. We don't need the parentheses here. Whereas in this will access the variable directly or the property directly. And this is just another way of accessing it. So this. Yes. This line is looking for a regular method called num and would cause an error. So what's wrong with this method? We need this dot num, which is the correct syntax for creating an object literal. It's this. What should we add to the empty with discount method to return the cost of meatballs object with a $2 discount? So return this cost -2. What is a factory function? It is a function that returns an object. Given the following code, which expression will evaluate to apples? Refrigerator produce jar.fruit 0. And finally, how can we add a property to the object below? Once again, trying to remember. It's this one. Yeah. We could accomplish the same thing using dot notation. Bikes dot specialized equals red. Okay. Okay, we're done with the quiz. And we are jumping into a couple of projects. Is it 1 or 2? It is 2. Okay, so we'll tackle those after a break. Okay, we are back. Let's get into it. All right, so we have a project where a restaurant has hired you to create a function for their website that allows them to set a meal and price each morning for today's special. Use your knowledge of getters and setters to make sure anyone who uses the new function can generate a meal and a price for today's special without any embarrassing errors. All right. Let's start. So we'll hold the meal, price, and the respective getters and setters in an object named menu. So we have to create an object named menu. Okay, once again, I probably need my cheat sheet of objects, which should be somewhere here. Show just right here, and there we go. Okay. Oh, so okay, it's just equal, and we have that. So that creates an object named menu. The menu object will hold the meal and price of today's special as properties, and they shouldn't be altered directly. So underscore meal is meal. Oh, with an empty string. Okay. And and the same thing for price. Price with 0. Okay, so we know properties that begin with underscore should not be directly manipulated. But just to avoid this knowledge, just to validate this knowledge, let's test it out. Directly manipulate two properties by assigning meal. To see how not type checking these values could cause confusion for a website visitor. Well, we'll skip that. We already know. So to safely reassign the two menu properties, we can add setters that type check the values being assigned. So below the properties, these probably should have commas here. Below the properties, use the set keyword to create a meal setter method with meal to check as parameter. Okay, so set, let's just set meal to set, and we do this. Correct? Correct, I think. Meal implicitly has type any because its set accessor lacks a parameter type annotation. This is how you do it, correct? Or do we have our setters? Set name, and the parameter. Yes. So, in the body of the setter method, create an if statement that checks if meal to check is a string. If it is, return the object's meal property with meal to check assigned as a value. Okay. So if type of meal to, oh, it's supposed to be check, meal to check. Equals string. We simply return object's meal property with the meal to check assigned as a value. So, like this, menu dot this meal equals meal to check. Oh, we don't need the menu if we're using this, because it already references the menu object. So it's just this dot meal equals meal to check. Yes, I think so. And we do the same for price with price to check as a parameter. This method should make sure the value associated with price is always a number. Okay, so we just do set price. Wait, something is incorrect here. It should be here. Set price to check, and if type of price to check is number, and then we return this dot price equals price to check. Right, we can also, I guess, add an else statement that simply console logs meal name must be a string, and then also an else statement here that just console logs meal price must be a number. Okay, so that's done. Below the menu object, set the values of meal and price using the newly created setter methods. Then console log the menu object to check their functionality. Okay, so menu dot meal equals, let's say, ramen noodles, and menu dot price equals 250. And then let's console log the menu. Ooh, an expected identifier type of meal to check equals string. Is it just not seeing this? No, it's identical. Oh, we just have to do this. Wait, no. Huh. Unexpected identifier type of meal to check. If type of new name, yeah, we should be able to easily pass in the parameter variable here. Could the problem be somewhere else? Function load, company, blah, 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 rep save. Set menu. Set meal. I guess it doesn't like the name meal. Okay, meals. No, still doesn't like it. Property meal implicitly has type any because its set accessor lacks a parameter type annotation. Infer type meal. So, no, that didn't do anything. Uh, set meal. Set name. New name. And then we use that. Wait, type of. Oh, there isn't a uppercase O in type of. Oh, still not happy, but this time it's about the price. There we go. Wait a sec. We got something wrong here. So it did set the price and the meal, but it also did something weird. Meal setter, price setter. This price to check. Getters and setters. My get name. Now this is how you set it. It's not like you have to pass in the parameter itself, because it gets passed automatically through here. So we're passing in things correctly. But why are we getting these two? Is the question. Wait, what if we just comment this out? Okay, we get nothing. So it is definitely within the menu object. We create, for some reason, two new different parameters. Property price implicitly has type any. Huh. Yeah, meal. Return this dot slash underscore name. In a setter, we do this dot underscore name equals name, which is exactly what it's here. What are we doing here? Return unless we have to do it in a separate sort of line. Okay, let's say this and then return. Oh, we don't have to return anything here because we're simply setting the objects, the properties. So, no, still something's off. like I'm missing something very basic. Getters and setters, intercept property access. Yeah. And allow additional actions to be performed before these changes go into effect. And here, in the setter method example, there is no return. We simply modify the property. Okay, what if we change this to an integer? So we get a single property with meal being empty. Or is this just how it's displayed? Ramen noodles. Like, is that just the convention that it's displayed if you just print out the... Okay, what if we print out menu meal undefined? Oh, underscore meal. Underscore meal. Ramen noodles. Okay, and price is $2.50. But if we print out the whole menu, I guess it just shows that the meal is a setter and price is setter. It's an interesting way of denoting that, but I mean, I guess it works. Okay, so now it's time to safely return the values of meal and price properties in a readable form. Instead of directly accessing the properties, we can use a getter method that proactively checks if a meal and price have been properly set before returning these values. So below the setters, you can delete all of that, and below the setters, use the get keyword to create a today's special method and leave the function body empty for now. Okay, so here we add a comma and we simply write get today's special. Today's special. I'm thinking now, getters don't really need to have any arguments passed in. So we just do this, and I guess we just check if okay, well, let's leave it empty for now. So in the body of the getter, create an if-else statement, check if meal and price value exist. Oh, so we don't really need to... Right, it makes no sense. Why would we access it through the setters when we have direct access to the object's properties themselves? So if this meal and this dot price then we simply return a string with Today's special is this meal for this price. Right? Otherwise, we can simply return a string that just says meal or price was not set or set incorrectly. I think that's how it's typed. Spelled, I mean. Alright. So finally, use the getter method to console log today's special. He's such a goof. Trying to find an angle. Okay. Okay, so we just console log today's special. Yeah, so menu dot today's special. Oh, we didn't set the price yet. So menu dot meal, let's set that to I don't know, lasagna. And menu dot price, let's set that to $5. Just gonna change a thing here. There. Oh, it's supposed to be a number. There we go. For $5. Okay. So it works. And then we can easily reassign anything we want. So let's say oatmeal. Yep. Or popsicle. Yeah, it works. Okay. The second project is team stats. We want to create, retrieve, and add information about your favorite sports team. Basketball, soccer, tennis, or water polo. You pick it. It's your job to create data using the JavaScript data structures at your disposal. Arrays and objects. After we create these data structures in the project, feel free to challenge yourself to gain insight from them. For example, you might want to get the total number of games your team has played, or the average score of all their games. Alright? So, let's make a data structure to store the information about our team. Declare a const variable called team, and set it to an empty object. Already done. Our team has players and the games that they played. Let's represent both of these by adding two properties to your team object. Add a player's property and a game's property, and initialize both to empty arrays. Okay, so we have players, players, empty arrays. Okay, and games. Wrong underscore. Games, empty array. Donezo. Next, populate the empty players array with 3 players. Each player should be an object containing 3 properties: first name, last name, and age. Put each player on a new line to prevent the line from getting too long. Okay, so the players array should be another object wait, let's do this and do mark, wait, something's off. Oh, I suppose we need to instantiate an object. So player 1, and then we do first name. Let's say Mark. Right? Or do we not really need this? I don't think we do. As far as I remember. Just simply open the brackets and we can type in first name Mark, last name, let's say Cool, and age, say 32. Right? And then after this, we can open a new bracket and do the same thing. First name John. Japchen. Let's call him Japchen. Last name Boone. And age 55. Yeah, he's 55. He's still playing basketball. What are you going to do about it? Probably nothing. And finally, we have the last player. First name Keegan. Last name Bully. Age 12. That's a wacky basketball team, but, you know, it is what it is. So, this should technically, if we now console log, let's say team dot players and 0. First name Mark Cool, age 32. And the last one should be Keegan Bully, age 12. Okay, we shouldn't be accessing it like this, but just for testing purpose, it's fine. Okay, so that works. Let's do the same for our games array. Populate the empty array with 3 games. Each game should be an object containing 3 properties: opponent, team points, and opponent points. All right. So we just open this and just add the games, I guess. So opponent will be, I don't know, Chicago Bulls. I don't know what kind of game is this with just three players in each team, but you know. So team points. We obviously crushed them. So let's do 75 and opponent points will be 12. Yeah, they sucked. Right. And so we open these brackets, we just do this, add a comma, and open new square brackets, and continue writing. So opponent, this is really testing my American basketball team knowledge. I don't know, let's call Lakers. I don't remember which state they belong to, but team points, let's do 56, and opponent points, let's say they beat us by 1 point, 57. All right, and finally the third game. We can do, is it New York? I want to say New York Lakers. Knicks versus Lakers. Los Angeles Lakers. It's New York Knicks. Okay, let's change this. LA Lakers, and we'll do New York Knicks. Team points will be, let's say, I don't know, 32, and opponent points will be let's say minus 12. They were pretty bad. Okay, so that should conclude this task. Now we have to create a getter method called players to retrieve the player's property. Inside, we just return the player's property. For the scope of this project, we won't need to create setter methods because we don't want anyone to change the data saved to the properties. All right, so let's see. So here, correct? We just create a getter method, players, which will simply return this dot players. Is that right? Wait, setters, getters. Get. Oh, it's fine. I thought I thought this was supposed to light up some different color, but it's not supposed to do that. So it is fine. And we create another getter method called getGames. So get games, and we simply return this dot games. Wait. No, it should be fine. Right? So, because now if we test it, let's say we want to get all the players. Let's console log team.players. Yeah, we get all the players. Well, we get an array of players, because that's what we were supposed to do. Yeah, populate the empty players array with 3 players. Yeah, okay. All right, we want to add a new player to our team. Add a dot add player method to the team object. This method should take 3 parameters: new first name, new last name, and new age. Okay. So we add a comma here, and we just include a add player. Now back to instantiating functions. Within an object. No, yeah, that's how you do it. Just write the name, parentheses, and it should be fine. So parentheses and this. Okay. So this method should take, oh, right. This method should take 3 parameters: new first name, new last name, and new age. Okay. So we have to create a new player object by setting the 3 parameters to be the values for the object's 3 properties. Are we meant to use the assign method? Because, yeah, I think so. Wait a sec. Assign. No, but assign, it doesn't modify the original object. If we want to do that, we simply do team dot players equals new first name, new last name, and new age. That did not do anything yet because we didn't call it. So if we go team.add player and say we pass in Jube Muckleberry, age 70, age 98. It replaced everything. Inside the method, create a player object by setting 3 parameters to be the values for the 3 properties. Okay, const player equals by setting the 3 parameters to be the values for the object's 3 properties. Okay, so first name is new first name. Last name is new last name. And age is new age. Finally, add the player object to the team's player array. Okay, so we can just this dot players, because that's an array, dot push player. No. Unexpected token dot. Or do we just do just players? No. Wait, is it just team players? Team underscore players. No, Let's take a look. JavaScript. Maybe I'm using the push method incorrectly. Push. Let's see. So we have an array. So array dot push something. I mean, technically we should be using it correctly. Team.players is our array. But in this case, we're accessing it as this players. No, it still doesn't like it. For whatever reason. But this should be how you access that array. Underscore players. This dot underscore players. Wait. Why are we... Why do we have a variable here? Count. While pushing. It's very interesting because this variable gets assigned a number via the push method. And animals and the cow gets pushed onto the array. But we can use it as a standalone as well. Through here, like so. And then we log animals, and chickens, cats, and dogs gets appended to the end. Getters and setters. Restrictions, accessing. Dot notation for accessing properties. Passing objects as arguments. No, that's not exactly what we need. This keyword, reserve keyword this, refers to a method's calling object, and it can be used to access properties belonging to that object. Yeah, so we have cat object with a name property. And then within that object, on a separate method, we call this .name. So in here, we should be able to oh, I see. Here's the problem. This was supposed to happen here. There we go. Okay. Curly brackets confused me. Okay. Then it's fine. It's fine. Alright, so we have an add player function working, or a method. So below the team object, let's try out the new add player method to add a new player, Bugs Bunny age 76. And log the team's players property to check that our player, we've already done that. So the scorekeeper has some new information for us. Create a method for adding game results called addGame that takes 3 parameters. So we just have to do the same thing with the games, right? Parameters to be values, blah, 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 blah. Add the game into the object's team games array. Yes. So add game and new opponent, new new team points and new opponent points. Correct? Correct. Not like this. Like so. And we just have const game, initialize a new object with the opponent being new opponent, the team points being new team points, and finally opponent points being the new opponent points. Right, and then immediately after that, we simply wait. That is the object. Yeah, so immediately after this, we just go this games dot push game. There we go. So add a record of a new game. So team dot add game Titans we scored 100 points and the opponent scored 98 points. And we just log the team's games property to check out if the game was added. And it indeed was. All right. That's a neat little project that made it a little bit clearer for me how things are added, modified, checked, and whatnot. Cool. Next. What have we got next? Documentation, JavaScript objects. So the provided link goes directly to the go-to documentation for JavaScript objects. This is helpful if you'd like some further guidance on how the object class works, constructing objects using static methods, instant properties and methods, and some examples of object usage. Instead of trying to remember it all, use the documentation as a readily available resource for syntax or implementation help. Will do. Okay. Higher order functions. Lots of reading. Let's take a look. That's a new chapter. We still have iterators, higher order functions, and iterators project. Oh, that's just part of the higher. Oh, we're in iterators now. I think I skipped a page or something, because it's not really clear what we're talking about here. But we're at iterators right now. So iterators, then we have errors and debugging, pair programming. My God, there's a lot still left. All right, so we are often unaware of the number of assumptions we make when communicating in our native languages. If we told you to count to 3, we would expect you to say the numbers 1, 2, and 3. We assumed you would know to start with 1 and end with 3. With programming, we need to be more specific with our directions to the computer. Here's how we might tell the computer to count to 3. So, for index starting from 1 to 3, while the index is less or equal to 3, index plus 1, and then log the index. So when we speak to other humans, we share a vocabulary that provides quick ways to communicate complicated concepts. When we say the word bike, it calls to mind a familiar subroutine. Oh, bake, sorry. It calls to mind a familiar subroutine, preheating an oven, putting something into an oven for a set amount of time, and finally removing it. This allows us to abstract away a lot of the details and communicate key concepts more concisely. Instead of listing all those details, we can say, we baked a cake, and still impart all that meaning to you. So in this lesson, we'll learn how to use abstraction in programming by writing functions. In addition to allowing us to reuse the code, functions help to make clear, readable programs. If you encounter count to 3 in a program, you might be able to quickly guess what the function does without having to stop and read the function's body. We're also going to learn about a way to add another level of abstraction to our programming, higher order functions. Higher order functions are functions that accept other functions as arguments and or return functions as output. This enables us to build abstraction on another abstraction, just like we hosted a birthday party as an abstraction that may build on the abstraction we made cake. Okay. Not sure why that is necessary, but using abstraction allows us to write more modular code, which is easier to read and debug. Okay. So functions as data. JavaScript functions behave like any other data type in the language. We can assign functions to variables For some reason, I'm getting very yawny. It's probably a sign of lunch approaching. So. Uh, wait. Oh, never mind. Just looking for a thing. So. Thor has changed position. Oh, oh, oh. There we go. Where was I? We can assign functions to variables, and we can reassign them to new variables. True. Below, we have an annoyingly long function name that hurts the readability of any code in which it is used. Announce that I'm doing this important work. Let's pretend this function does important work and needs to be called repeatedly. To rename this function without sacrificing the source code, we can reassign the function to a variable with a suitably short name, which is busy. Busy is a variable that holds a reference to our original function. If we could look up the address in the memory of busy and the address in the memory of announce that I'm doing important work, they would point to the same place. Our new busy function can be invoked with parentheses as if that was the name we originally gave our function. Notice how we assign the announce that I'm doing important work without parentheses as the value of the busy variable. We want to assign the value of the function itself, not the value it returns when invoked. So in Java, functions are first-class objects. This means that, like other objects you've encountered, JavaScript functions can have properties and methods. Wait, what? JavaScript functions can have properties and methods? Since functions are a type of object, they have properties such as length, name, and methods such as toString. Huh. So functions can have other functions inside them. I guess it's a type of abstraction, but still. Uh, so functions themselves are a type of object. And so when we initiate a function, it automatically gets assigned default parameters such as length and name. And it has methods. set to a provided value optionally with a given sequence of arguments preceding any provided when the new function is called. So difference between function constructor and a function declaration. Functions created with the function constructor do not create closures to their creation contexts. They always are created in the global scope. When running them, they will only be able to access their own local variables and global ones, not the ones from the scope in which the function constructor was created. Okay, let's let's pretend I understand this. So where did we left off? The documentation. Functions are special because we can invoke them, but we can still treat them like any other data type. Let's get some practice doing that. Let's. So we've defined a function with a very long name. Check that +2 equals 4 a million times. Okay, this function takes a long time to execute. It checks whether 2 + 2 equals 4, but it does it a million times, just to be really sure. Using const, declare a new variable is 2 + 2 that will be easier to work with, and assign the function as its value. So const is 2 + 2 equals this. Right? Right. And we can invoke the function with just is 2 + 2. Okay. So if we forgot the name of the original function, is there a way we could figure it out? Use is 2 + 2 to console log the name property of the function we assigned. Okay, so we can just do console log is 2 + 2 dot name. Yeah. Okay, this is interesting. Functions as parameters. As you know, a parameter is a placeholder for the data that gets passed into into the function. Don't mind me, Thor. Just messing with the camera. God. There we go. Since functions can behave like any other data type in JavaScript, it might not surprise you to learn that functions can accept other functions as parameters. A higher order function is a function that either accepts functions as parameters, returns a function, or both. We call functions that get passed in as parameters callback functions. Callback functions get invoked during the execution of the higher order function. When we invoke a higher order function and pass another function in as an argument, we don't invoke the argument function. Invoking it would evaluate to passing in the return value of that function. With callback functions, we pass in the function itself by typing the function name without the parentheses. This is a mind breaker of a block of theory. So we have a function. We're passing in a parameter. And then we call that function inside this function. And then we return, I just invoked this as a callback function. Right. And then we have another function which just returns I'm being invoked by the higher order function, and we pass the second function as the parameter for the first function. Okay, so we wrote a higher order function that accepts a single parameter, param. Inside the body, param gets invoked using parentheses. And finally, a string is returned telling us the name of the callback function that was passed in. Below the higher order function, we have another function aptly named another function. This function aspires to be called inside the higher order function. Lastly, we invoke the higher order function, passing in another function as its argument, thus fulfilling its dreams of being called by the higher order function. Oh my god. So in this example, we invoked higher order function with an anonymous function, a function without a name. Whoa. What? That counts to 10. Anonymous functions can be arguments too. Holy crap. All right, let's get some practice. So here we have a function, add2, that adds 2 to whatever is passed into it. Below that, we created what will be a higher order function. Check consistent output. The purpose of the higher order function will be to check the work of add2. So to begin, inside the body of check consistent output, declare two variables. Okay. So check A will be equal to val plus 2, and check B will be equal to, check B stores the invocation of the function callback with the val as an argument. So check B will be function val. No. Oh, func, not funct. Okay, next, below the variables, write a conditional statement that checks if the value of check A is equal to the value of check B. And if true, return the result of the callback function. False, return the string. Okay, so we can do check A equals check B. And if that's the case, we return the result of the callback function. So func val. Otherwise, we return inconsistent inconsistent results. Well, I guess we can just do check A here. Huh. JavaScript. I feel like I keep forgetting how to use ternary operators. I think it's called ternary. Yes. Oh, we just we have to do return. Yeah. Okay, so finally, using the console log the invocation of checkAssistantOutput with 2 arguments, the addTo function and any number. So check consistent output with addTo. Wait, do we need to pass it as a function? I think so. And like, let's say the value. Missing parenthesis after argument list. 1. Yes, it is. How did we miss that? Func is not a function. So maybe we just do that. Yeah. Okay. This sort of makes sense, but applying it in practice probably will be harder than this. And if we mess this up, we get inconsistent results. Okay. And the review. Oh. My alarm clock is telling me that it's time for lunch and it's time for Thor's walk. So let's use that opportunity to take a break, eat some food, stretch our legs, take. All right, we are back. All freshed up, ate my lunch, took the dog out. And we can get back into more JavaScript. Okay, so we are looking at iterators. So imagine you had a grocery list and you wanted to know what each item on the list was. You'd have to scan through each row and check for the item. This common task is similar to what we'd have to do with if we want to iterate over a loop. Or, I mean, through an array, or loop through it. One tool at our disposal is the for loop. However, we also have access to built-in array methods, which make looping easier. The built-in... one second. There we go. The built-in JavaScript array methods help us iterate are called iteration methods. At times referred to as iterators. Iterators are methods called on arrays to manipulate elements and return values. What are you looking for there, huh? So in this lesson, you will learn the syntax for these methods, their return values, how to use the documentation to understand them, and how to choose the right iterator method for a given task. So let's see the output. Okay. So we have the first array artists, and we are, for each artist, we are printing artist plus a string. Okay. Then we have numbers. And we have the map function. Which returns number times number. And console log square numbers. Oh, so these are array methods. Okay. I was still on the function logic, and I was like, where are the functions? But these are essentially functions. And then we have log, which... Oh wait, no, we never mind, we're just printing this out. And then we have things, and we filter out things that are of the number type. Okay, makes sense. All right, let's move on. So we have the for each method first. So the first iteration method we're going to learn is for each. Aptly named for each will execute the same code for each element in the array. So the code above will all log a nicely formatted list of the groceries to the console. I guess iterators have a different meaning in JavaScript, because in Python, iterators are essentially functions with a different return statement that allow you to return values from an array one by one with each function call, instead of returning the entire array, like in sequential order. So the code above will log a nicely formatted list of groceries to the console. So groceries for each calls the for each method of the groceries array. For each takes an argument of callback function. Remember, a callback function is a function passed as an argument into another function. Okay, so we are essentially here writing a an anonymous function within the for each function. I think. For each loops through the array and executes the callback function. For each element. And during each execution, the current element is passed as an argument to the callback function. And the return value for each will always be undefined. So another way to pass a callback function for each is to use the arrow function syntax. So for each grocery item, we want to console log the grocery item. We can also define a function beforehand to be used as the callback function. So we have a function print groceries, and for each item in groceries, we print groceries. Oh, it then automatically passes in the arguments for this function. Interesting. The above example uses a function declaration, but you can also use a function expression or arrow function as well. All three code snippets do the same thing. In each iteration method, we can use any of the three examples to supply a callback function as an argument to the iterator. It is good to be aware of the different ways to pass in callback functions as arguments in iterators because developers have different stylistic preferences. Nonetheless, due to the strong adoption of E6, ES6 will be using the arrow function syntax in the later exercises. Okay, so we want to iterate over the fruits and log I want to eat a plus a name of each fruit to the console. Okay, so we have fruits, and I suppose we just do fruits dot for each and then the arrow function console log I want to eat a wait. Oh, we have to actually item, let's say. And then we just pass an item here. No. Fruit is not... Oh, fruits. Right. We can do fruit here. Right. And fruit here. There we go. Okay. Once again, it's probably just the logic is clear, but it's the syntax, the different ways of writing it is what's gonna trip me up probably. Then we have map. The second iterator we're gonna cover is map. When map is called on an array, it takes an argument of a callback function and returns a new array. So we call map on numbers. And so for each number in numbers, we're gonna multiply the number by 10. So it works in a similar manner to for each. The major difference is that map returns a new array. So yeah, number is an array of numbers. Big numbers will store the return value of calling map on numbers. Numbers.map will iterate through each element in the numbers array and pass the element into the callback function. Return number times 10 is the code we wish to execute upon each element in the array. This will save each value from the number array multiplied by 10 to a new array. Okay, let's try it out. Add your code under the animals array before the line console secret message.join. Use the map to create a new array that contains the first character of each string in the animals array. Okay, so secret message equals animals dot map, and we want to map animal for each animal. We want to return new array that contains the first character of each string. Oh, so we just return animal 0, right? Yes. Hello world. And then we can use the same map function to divide all the numbers by 100. Okay, so const small numbers equals big numbers dot map, let's say b num, and then return b num divided by 100. Yeah, it works. Right? Right. Okay, let's move on. Then we have filter. Another useful iterator method is filter. Like map, filter returns a new array. However, filter returns an array of elements after filtering out certain elements from the original array. The callback function for the filter method should return true or false. The callback function for the filter method should return true or false. Oh, right. Yeah, because it's filtering, it's checking against something. The callback function for the filter method should return true or false depending on the element that is passed to it. The elements that cause the callback function to return true are added to the new array. Right, so we have words, and we're filtering out words that are of length less than 6. Declares a new variable that will store the returned array for invoking filter. The callback function is an arrow function that has a single parameter word. Each element of the word array will blah, 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 blah. Okay, we get it. Let's call the filter method on random numbers to return values that are less than 250. Save them to a new array called small numbers. Right? Small numbers. Oh, wait. Small numbers equals, calling it in the wrong place too. Here, small numbers equals random. Oh, come on, Codecademy. Random numbers dot filter oh yeah, okay. Num, it's the same thing. Num and then return num less than 250. Right? Right. All right. Now let's work with strings. Invoke filter on the favorite words array and return elements that have more than 7 characters. Okay, const long favorite words. Long favorite words equals favorite words dot filter, and then we do word word and return the words that are word dot length is greater than 7. Oh, favorite words, favorite words. No, something wrong. Did you call filter on favorite words and save the return value to long favorite words? Yes, but again, the word favorite is difficult to spell. Then we have find index method. We sometimes want to find the location of an element in an array. That's where find index method comes in. Calling find index on an array will return the index of the first element that evaluates true in the callback function. Okay, so we have jumbled numbers and we're looking for the first element that is less than 10, which would be the third index position. Okay, so we want to invoke find index on the animals array to find the index of the elements that has the value of elephant and save the return value to a constant variable named found animal. So const found animal equals animals dot find index animal. Oh, wrong parentheses. Return animal equals elephant. There we go. Let's see if we can find the index of the first animal that starts with the letter S. Okay. So another variable const starts with S. Animals dot find index animal return animal 0 equals S. Okay, we got it. Reduce. Another widely used iteration method is reduce. The reduce method returns a single value after iterating through the elements of an array, thereby reducing the array. Okay, so we have an array. We're calling reduce. We have an accumulator and current value. Here are the values of accumulator and current value as we iterate through the number array. So the first iteration, accumulator equals 1. The current value equals 2. The return value is 3. So it essentially adds stuff. Okay, he's hiding. He's camera shy. He's scooching away from the camera as if he can feel it's recording him. Okay. You don't like being recorded? No? Okay, I'll leave you to it. So, some nums variable that stores the return value of invoking reduce. So then 3 and 4, 7 and 10. Okay, but I suppose we can use whatever we want operation on here. We just assume that it's going to reduce takes 2 parameters, 2 arguments, or 2 variables as parameters, and it just performs whatever you tell it to perform. Yeah, that's likely. Oh, but we can also have a second argument. The reduce method can also take an optional second parameter to set an initial value for accumulator. Aha. Okay, so we just set the initial value. And if we don't, it is set for us. But it's a weird way that it's calling. Like, or it's a weird placement for the second argument. Reduce opens here. Well, no, I guess it makes sense because we're passing in an entire function here. And then this is the second argument placement. Okay. Let's practice calling reduce. So we have new numbers. Let's declare a new variable. New sum. equals value of calling reduce on new numbers. Okay, so just new numbers, numbers dot reduce, and so the first argument will be the function that we want to reduce by. Oh no, we need to pass in the two. Right, first we need to pass the, say, num1. We have to pass in the accumulator and the current value. Right. And then this will go here, and then we return accumulator plus current value. Right. Okay, my order is coming in 15 minutes, so I gotta keep an ear out for that. So, to check the value being used as we iterate through the array, add 3 statements to the function body of the callback. Console log the value of accumulator. Console log the value of current value. And a return statement that adds accumulator to current value. I think I already... Oh no. Okay, let's console log. So the value of accumulator is accumulator, and the value of current value is current value. All right, so this is the first iteration. It's 1 and 3. That returns 4. And so the second iteration is 4 and 5, which returns 9. And so the third iteration is 9 and 7, which in turn should return 16. Well, we have this code set up. Let's also check what happens if you add a second argument to reduce. The second argument acts as the initial value for the accumulator. So add a second argument of 10. Right, so we start with 10 and 1 here. And we have an extra iteration because we don't get access to the second value in the first iteration. So this is the first one, this is the second one, third one, and finally the fourth one, and our output is 26. Got it. And we have documentation. There are many additional built-in array methods, a complete list which is on the MDN's array iteration methods page. The documentation for each method contains several sections. Short definition, a block with the correct syntax for using the method, list of parameters the method accepts or requires, a return value of the function, an extended description, examples of the method's use, and other documentation. Okay, let's see. So in the code editor, there's an array called words. We want to create a new array of interesting words. The first thing we want to do is check if there are words that are fewer than 6 characters long. There's something missing in the word sum method call. Fix this method so that true is printed to the console. There is something missing in the words sum method call. Okay, let's take a look at what sum does. Sum method of array instances tests whether at least one element in the array passes the test implemented by the provided function. It returns true if the array... Oh, it returns true if in the array it finds an element for which the provided function returns true. Otherwise it returns false, and it doesn't modify the array. So, by calling sum, we have to pass it an expression of sorts, or rather a function. I guess an evaluator function that checks, that does the checking. So here we are missing that. Wait, it's it's kind of written wrong. Where is it? Some. Huh. We are supposed to pass it a function. But instead, what we're doing is we are essentially making it into just a function. Huh, I don't understand. Or are we just supposed to type in here a word and that's it? Oh. Oh, we can use it the same way as filter and all the other ones. We just call it with a parameter that we're iterating with, and we're checking against that parameter. Okay, so the sum method returned true, which means there are some words in the array that are shorter than 6 letters. Use filter method to save any words longer than 5 characters to a new variable called interesting words, declared with const. Alright, so we simply create a new variable. Interesting words. And we call, right, And then we do words dot filter word, and we return if the word dot length is greater than 5. Wait. Length. There we go. In the last line, we have this code. Complete the code between the parentheses to check if every element has more than 5 characters. So, we're doing the same thing. We are just writing this function thingy, just a return statement, I guess. Return word dot length is greater than 5. Okay. So essentially the syntax is pretty much identical to the functions before that. There are many iteration methods you can choose. In addition to learning the correct syntax for the use of iteration methods, it is also important to learn how to choose the correct method for different scenarios. The exercises below will give you the opportunity to do just that. You'll see errors pop up in the terminal as you work through this exercise, but by the end, the errors will be gone. Alright, so replace the word method in the first method call with a method that will do something for each of the values in the array and return undefined. Oh, okay. So for each, yep. In the second method call, replace the word method with a method that will return a new array with only those elements longer than 7 characters. So I'm guessing filter. Yeah. In the third method call, replace the word method with a method that accepts an array containing multiple values and returns a single value. What are we doing here? We're reducing? Yeah. Reduce. And then finally, well, not finally, but in the fourth method call, replace the word method with a method that will return a new array of numbers returned from the function. So wait, we had reduce. What was this one? Okay, let's look at array methods. Have slice, sum, map. Maybe. Yep. Which is interesting because map is sort of identical to for each, but okay, whatever. In the fifth method call, replace the word method with a method that will return a Boolean value. So clearly that is just sum. Yep. All right. Okay, so just to recall, for each is used to execute the same code on every element in an array but does not change the array and returns undefined. Map executes the same code on every element in the array and returns a new array. Oh, I'm getting my package, so 1 second. Okay, took the package, can get back to things at hand. All right, so filter and checks every element in the array to see if it meets certain criteria and returns a new array with the elements that return true for the criteria. Find index returns an index of the first element of an array that satisfies the condition, and reduce iterates through an array and takes the value of the elements and then returns a single value. All the iteration methods take a callback function which can be predefined, which can be a predefined function, a function expression, or a function, or an arrow function. Right, so we can predefine functions. We can write a function, then pass it into that function. It's a callback function. It's a whole callback function deal. Okay, get it, got it. Let's go. All right, in the following JavaScript code snippet, the callback function CB is a function that sums the value of two numbers. Fill in the blanks so that when the function is passed into the higher order function hof, it is then invoked so that the value returned is 8. So CB, we pass into numbers and return number 1 plus number 2. And the h of function why are these different? 3524. What's up with these numbers? CB 3 plus 5. 3 and 5. 2 and 4. We're passing in the function to h of. Then within h of, we assign the variable value to a function call of specific values. So I'm assuming it's this. Because we pass CB here, we don't need to call it again here. I guess just one of the two options. I don't think there's a difference in between the numbers. You can pass whatever numbers you want. Oh, so that the function returned a. So that, Jesus. I completely missed this part. So that it returns 8. Right, so this is the correct one. I would have gotten the right answer, but for the wrong reasons. Yeah, because this would return 6. Okay, a code snippet includes a function assigned to the variable sum. Given the fact that JavaScript functions are first-class objects, fill in the blank so that a property of sum, called alias, is assigned the string value summation. Excuse me, what? Given the fact that JavaScript functions are first-class objects, fill in the blanks so that a property of sum, called alias, is assigned the string value. Oh, so sum.alias equals summation. Yeah, because property alias, and alias is we access properties with a dot, is assigned the string value summation. Yes, that's the correct answer. Final answer. What is the value of found element after the code runs? We are doing what? Finding index of the first value that is higher than 200. And that would be 3,543, which is the index 4. So it will return 4. Yes. Use map method on the odd numbers array to return each number multiplied by 2 into the even numbers array. Okay, so odd numbers dot for each. For each number in the array, we want to return number times 2. Correct. Yay. Select the option that correctly assigns the increment function to the variable increment holder. Select the option that correctly assigns the increment function to the variable increment holder. Right, so we have a increment function that has one parameter, salary. We are adding +5 to the salary, printing it out, and returning the revised salary. So the variable increment increment function to the variable increment holder. This one. Yes, because we don't need to pass in any arguments to reassign the name of the function. Okay, which of the functions represents a higher order function? Alright, so this is just a normal function. This val normal function. This is just taking, well, this is taking a function as a parameter and then using it to, right, so probably is a higher order function because it's using two functions. And then this one is multiply two values to 2 square result. Well, get function string is the higher order function. Yes. Which of the following iterator methods return undefined? It is. Let me think. Sum returns true or false. Map returns an array. For each returns nothing. It does something. And filter, it returns an array as well, so for each. Okay, which of the following methods returns an array with values that evaluate to truly based on the condition of in the methods block? Sum and filter. Based on the condition in the methods block. It's either filter or sum, because sum also has a condition, but that condition is, oh, returns an array. Sum doesn't return an array, filter does. Okay, and fill in the blanks to make added up log 100 to the console. So we have a number array, initializer 90, added up nums dot reduce, probably accumulator initializer, and that will be 610, so we just need to do accumulator plus current value. Wait a sec. Current value? Yes. And finally, right, initializer here. Now I'm questioning whether it was actually reduce or map. No, map returns an array. Reduce returns a single value. So that's what we need to do. Yep. Wait, which one did I get incorrect? What? It says I got one incorrect. Let's try it again. Which of the following methods returns an array with values that evaluate truly based on the condition of the method's block? Returns an array, and that is filter. Okay, that's correct. Which of the following iterators returns undefined? For each. That's correct. Which of the functions represents a higher order function? Get function string. Correct. This was .alias equals summation. Correct. Fill in the blanks to make added up log 100 to the console. So nums reduce current value initializer accumulator. Correct. In the following JavaScript code snippet, the callback function CB is a function that sums the value of two numbers. Okay, it was func35. Correct. Select the option that correctly assigns the increment function to the variable increment holder. So this. Correct. And use the map method to on the odd numbers array to return each number multiplied by 2 in the even numbers array. So odd numbers dot map number times 2. Check answer. Correct. And finally, what is the value of found element after the code runs? So we have random numbers. And we're looking for index of a first value of a number that's higher than 200, which is 3,543. Which is an index of 0, 1, 2, 3, 4. So 4. Correct. What? I did everything exactly the same, and now it's 100%, where it was 88% before. This is crazy. Okay, let's move on. We have grammar checker. Oh my. My goodness. In this project, you'll use what you know about iterating over arrays to gather information and improve the quality of a paragraph. Alright. So it's like 12 steps. Okay, before we do that, let's take a little break. As per usual, 10 minutes, and we'll be back to tackle and we're back. Guess who's back? Back again. Thor is back. Tell a friend. Alright, grammar checker. So, we have a block of words. And right, we're probably gonna have to use a bunch of array methods. So, the story variable holds a paragraph we'll be editing. In order to edit the story, we turn it into an array on line 3. Yes, we do. Story words. The split method separates the story string by the space characters and stores each word as an element of the array. To see the array, we'll be working through the lesson, log story words to the console. All right, let's take a look. Okay, still has parentheses and stuff. And periods. 81 more items, okay. So, I'm gonna create a new variable, say specials equal, and this will be an array with commas, dots. What else have we got here? Exclamation marks. And we also have a loose sideways dash. What else? What else? What else? What else? What else? Oh, it's not gonna get filtered out this way. We also have numbers. That's fine. Right, to the beautiful. Let's make this into an array as well. Oh, oh. And then it. Okay. Right. So exclamation marks, periods, dots. What else have we got here? Okay, that's about it. So, for a better visual comparison of the original and edited stories, we want to view the edited story words array as a string. To change story words array back into the readable string, we can invoke the join method on story words. Give the join method an argument of an empty space character to separate each array element with space in the string. Place the join element invocation as an argument of a console log statement to log the final story to the console. Okay, so story words dot join empty string. Okay. So we basically got the same thing, except now we have the whole story in another variable, which seems unnecessary, but okay. Now it's time to start editing the story by manipulating the story words array. We want to be able to see changes, so be sure your console log of the joined story is in the last line of the code in your editor. First, above the console log statement that uses join blah blah blah, create a variable in count that stores number 0. Why? But okay. Directly below count, use for each method to iterate over the story words array. As an argument for each method, create an empty function to be used. What are we doing here? Directly below count, use a for each method to iterate over the story words array. As an argument of the for each method, create an empty function to be used as the callback function. I swear to God, sometimes the descriptions of this thing are so confusing. Fine. So, story, words, for each. Okay. So I guess that's done. So for each word in story words array, we want to count. We want the count variable to increment by 1. Add a parameter word to the callback function of the for each method to be used to store the current element when iterating over the blah, 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 blah. So first of all, we just increment count by 1. Right. Below the for each method log count to see how many. All right, let's do it here. Log, and then we can do word count. Count. There we go. 181 words. All right. A word count of 181 is a bit long for this story. Let's filter out all the instances of the word literally. Shorten the story and remove the unnecessary word. We will reassign the filter's story to the same story words variable by applying the filter method. Throughout the project, we'll use this approach to reassign the story variable for each revision of the story. Below, where you log the count variable, reassign the story words variable to equal the invocation of filter method of the story words array. All right, so story words equals story words dot filter, and we are filtering what for each word in the array, or yeah, for each word in the array we're filtering it out so that it returns only when the word does not equal, only if the word is not in. Well, okay, let's start easy. If the word does not equal bad word. Right? Right. Wrong. Uh, Ba-ba-ba-bow. Do we just reassign it? Like so? No. Yeah, it's already been declared. We just want to rewrite over the top. So storywords.filter word. Storywords is still an array here before we turn it back into. Well, we don't turn it back. We just need an array returned. But it's not returning. Wait, where's the... Where is the bad word? Something blah 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 blah. I don't see the bad word in here. Oh, there it is. Had a freaking long way to go. Wait, it removed a word, but the word count didn't change. Huh. What? Oh, because we're counting it before. Okay, so to make this a bit better, what did I do here? No, let's move this away. Right, because it counts here and it doesn't recount it afterwards. So let's turn this into a function so that we can just call it at the end. Let's see. Now I'm trying to think. Count equals. Right. Const count equals. Right. We don't need this variable here. We'll just have the function, and then we will call the function. Right? Can we do this? No. Cannot access count before initialization. It's been initialized though. What are you talking about? This makes sense? No. Oh, okay, never mind. That's not the problem. The problem is here, because this is now a function. And we have to do oh, so we do need a global variable. All right, let's say tracker equals 0, and then tracker plus plus. Right, so the count is not a function. You're not a function. Wait. Still not what I need. Oh, yeah, return tracker. Wait, no. Right, this doesn't work because for each iterates through the thing here. So it, okay, let's just go back to what it was. We can just recount it. Nope. Okay, it's not working anymore for some reason. Oh, there we go. Supposed to be like so. Right? Right. And then we do it again. Except before that, we have to set count back to 0. Right, we got it back. God damn, so confusing. But I still kind of want to make a function out of this. Let's see. How would we make a function normally, right? We would go const count equals, take a parameter, or we don't. Well, we do, but we don't. And then we define our function. Right? Right. So inside the function, we can define our variable that we'll be using. And inside, we can have this whole thing. And so after it runs, we just need to return count. Right? And then we do a function call. Right. Okay, I figured it out. I got them big brains for this. Right, it works. So if we comment this out, it's 181. If we uncomment it, it's 180. Cool. So this wants us to filter out the bad words. We've done that. Right? No, this, we're just doing count here. This one is for bad words. Story words, filter, story words variable equal to invocation filter methods, blah, 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 callback function of grammar word. Literally. Wait, what about bad words? Where does freaking go? Thought we did freaking. Never mind. I guess we'll do the same for literally. So filter word, bad word, and instead of bad word, we just do unnecessary word. It goes here. And now our word count drops down to 177. Okay. Then below the unnecessary word on line 4, we want to filter out. Wait, Didn't we just do that? We will reassign the filtered story, applying the filtered method. Okay, no, that's fine. So, below the story, declare a variable. Notice the variable necessary word on line 4. We want to filter out the word unnecessary word from the story. Right. If it's not equal to the bad word or the unnecessary word. Right, that's done. Replacing the words. Now that we remove the unnecessary words, let's take care of any misspelled words in the story. We can reassign story words to a new array of spell-checked words using the map method. Okay. So I guess it's going to be a bit different, a bit more difficult, since I've included this misspelled word. So reassign story words to equal the invocation of map method on the story words array. Sure, story words equals story words dot map. Set word as a parameter. Yeah, that's pretty standard. Word. And in the callback's body, define a conditional statement. To check if the word argument is equal to the misspelled word variable. If it is, return the correct spelling of the string. If not, return the word. Alright, so in this case, I guess we have to check against two words. So, if word, if the first, how should we do this? Oh, we can actually do if 0 and 2. I probably should put these in parentheses. So, if the first 3 letters of the word equal B, E, A, B, E, A, or word, the third letter of the word equals slash. Right. So if that's the case, then we have another if block. So if word, so if the first letter of the word equals B, then this needs to go into parentheses. Then we simply return beautiful, right? Trying to think here. Otherwise, return it. We're missing closing bracket somewhere. here. This is supposed to... I don't know. Let's just add it here. Ooh. Nope. Probably not here. Right, wait. Let's see. This one closes this one closes that one. So it's supposed to... This one closes that one. So we need another bracket here. That should close. No. Not here. Here. Right? Wrong. Or here. Or here. Oh my god. So this is supposed to cap this, so here. Getting confused here. Okay, let's delete all of them. So this closes this. This closes that. That could close this. Except it doesn't. Why doesn't this get closed? Oh, because it is thinking that... Right, for some reason. This parenthesis is being weird. Let's go back. Why are you being weird, parenthesis? What if we just delete it? No, it doesn't help. What if we do this? Then the parentheses are closed properly. But we are getting weird stuff happening. Okay. Huh. What happened? What spooked you? Something spooked the dog. You okay? Come here. Or... He got spooked by something in the hallway, probably. Now he's checking out, whatever that may be. Just standing in the doorway. Okay, so something weird is happening with this. Okay, well, we don't necessarily have to check it like that. We can just go from 0 to, I don't know, from 0 to the second element, right? If it equals, there's probably more it's in here. It's not a very good check. You can check the whole thing. So that will be, trying to think now. 0, 1, 2, 3. Sure. Let's just copy this whole thing. Right. Okay, so it should work. In the callbacks body, define a conditional statement, check if the word argument is equal to the misspelled word variable. If it is, return the correct spelling of the string. Well, if we had a lot of misspelled words, we would probably be checking this a different way. We would be looking for whether the words that we're mapping through are in the array. Then we would have to find that word's array position, and then we would have to change it. Yeah, but since there's only 2 misspelled words in this text, we can do it the easy way. So, technically, this should have... Okay. Unexpected token. Wait a sec. Is this not how you index splice? In JavaScript? Index splicing. Array splice. No. That's not what I want to do. Oh. Right, I do want to splice. Because... Yes. Yeah. I do want to splice, but I want to do it like so. If word dot splice and 2 and word dot splice 3, and that's fine. Okay, so now where word splice is not a function. Slice? Is it slice? No, it's splice. Huh. Property splice may not exist in the type string. Maybe I meant slice? Ooh, now it's just everything's gone. Interesting. Let's console log, see what's happening. Okay, so we're going along our path, blah, 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 blah. Wait, what? Oh, never mind. We're supposed to do word. Word equals beautiful. And then here we do the same thing. Word equals it's. Right? Where was it? It's really an adventure from beginning. It's really an adventure. Yeah. but we're still not getting the word back because we don't have a return statement, which should be where? Um, wait, what are we doing here? We are checking if the word, part of the word, equals beautiful, or B, or if part of the word equals its. If that's the case, all right, let's console log over here. See what happens. Nothing. Wait, what? So it... What? I don't understand. Here? Nothing. Someone spooked him so much. He is going to his bowl, which is in the hallway, and he's bringing food here to chew. Huh. This is odd, to say the least. Because we are replacing the word. Like... Right? It's really an adventure from beginning to end. So if we find this... Where is it? It's really an adventure. It's really an adventure from beginning to end. And the word literally as well gets replaced. Wait, no, not beautiful. Yeah, with two L's. Go up. Wait, no, that's how you spell beautiful. Is it? No, it's not. Okay, let's... I think something's going on with the word beautiful. Say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine. If the word equals beautiful... Nope. Still not replaced. Why does this get fixed? Maybe it was never fixed? come on. Fine, I'll leave the word count. Where is it? Word count. Here. Excuse me? Count is not defined. Yes, it is. What are you talking about? Count is definitely defined. There we go. So, okay, it's always printing it correctly. What in the hell? Oh, that's why it's done that. Okay, so I'm just a big stupid poopy head who doesn't know how to do things. Okay. Well, let's just scrap this whole entire thing. Well, matter of fact, we don't need to scrap the entire thing. We just need to scrap this. And we simply return if it is. We have to check if the word argument is equal to the misspelled variable. So, return misspelled word is equal to word. If so, hello, how can I help you? Can I help you? Hello, hello. Look here, Thor. Look here. Here. Boop. 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 Okay, I'm sorry. You're looking at me so seriously. No, he decided to lay just under the camera. Alright, nothing I can do about that. Or maybe I can. Can I? Yes, I can. Hello. Well, not really. Oh well. Let's leave it at this, in case you go back to your showing spot. Right. So if the misspelled word equals word, we do what? Right, we just return. Beautiful. Otherwise, oh, we don't need to return statements. Otherwise, we return the word. And it's done. Okay. So they suggest clearing the bad word with find index. but that's a bit of an awkward way to do that. Because the easier way to do this would be with filter, which we just did. But I guess we can do it. So they want us to declare a variable called bad word index. Bad word index equals index of bad word story dot index of bad word. And so we got the index, and now the find index. Oh, find index. Wait. Start by declaring a variable bad word index and setting it to the invocation of find index on the story words array. Sure. The find index callback function should check each word. Oh, so it works quite the same as it's a callback function. So, all right, I get it. So we just return if the word is equal to bad word, correct? Check each word to see if it equals to bad word variable and return the index of the found word. What? Return index of word? Story words. Index of word. Why can't I just get immediately index of? Oh, because it doesn't allow you probably to do direct searches. You would have to do a for loop. Whereas in this, we'll do the for loop in the background, I think. So if we console log bad word index, we will find that it prints 1. What? Oh. If word equals bad word. That somehow slipped my mind. Right, 80. Oh my god, I'm gonna have to count all the way down. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, close enough. So it's 80. There we go. Now that we have the index of the bad word, we can easily replace it with something more appropriate. Access the element inside story word array that has the index of bad word index using the bracket notation. Set the accessed element equal to the more appropriate string really. All right. I guess we can do that at the end here. So story story words bad word index equals really. And so didn't change. It didn't change because okay, let's console log story words bad word index way. Excuse me? It's checking for bad word. And bad word is freaking. Okay, something's off. So here, let's do a check. First of all, let's check the word. Word is, wait, bad word found, and word. Word. Freaking. Okay, so it found it. And it should return the index. Console log story words. Story words dot index of word. Freaking. Okay, so it works. So this returns bad word index. So then if we outside of this, if we console log story words bad word index, it's freaking. Okay. So replacing it, it's still here. What? Where did really go to then? What is it replacing? It's replacing way for some reason. Oh, because I'm still modifying text. I should be probably doing it here. So that way no other changes will happen in between. Nope, it's still there. What? Now I don't know what the problem is. uh, Wait. Console log. Console log this. It's way. Why is it way? Oh, we also have to do this after the whole thing. Right, I moved the wrong block code. And there we go. It's replaced. All right, so it's my own stupidity. Yeah, because we were finding the word before we changed some other words here, even though it shouldn't be deleting any words. Wait, no, it does. It literally does here. Right, we remove one word. We remove actually more than one word. Yeah, so this is the problem. So this should have gone either the replacement should have gone before this, or the finding of the word of the index should have gone after this, which we just did. Okay. Finally, wrapping my brain around it. It's fine. It's fine. Okay, finally, let's simplify the words in the story to appeal to a broader audience. We can make sure every word in the story is 10 characters or less using the every method. Okay, so the every method uses a callback function to test if every element in an array passes a specified condition. It returns true if all the elements pass, and false if there's an element that does not pass. Sure. So let's define a variable called length check. Length check. And set it to an invocation of every method on storywords. Storywords. Every word equals what? Come on, Codecademy. Right, so every word that is less than turn test whether every word has less than or equal to 10 characters. So return word dot length is less or equal to 10. Oop. Story word is not defined. Starting words. Looks like there's at least one word longer than 10 characters. Use an iterator method of your choice to access the word. There's only one in the storywords array that is greater than 10 characters. Then manually replace the word in the original story string with a shorter word. So the length check only stores the true or false, right? Yeah. So we need to independently do a check again, or we could modify this. So return word length does not equal is less. We could modify it like this and write a ternary expression. So if the word length is more than 10, we return, say, stunning, right? And otherwise, we return the word itself. Now we just have to find it somewhere. Wasn't it supposed to be breathtaking? Let's see. If word length is more than 10, yeah, breathtaking. So we didn't really change it. So, oh, we just have to do word equals stunning. Otherwise, return word. Can we do that? No. We have to... Okay, we can't do it with a ternary then. We just have to write this. If the word length is over 10... return stunning. Right? Else return word. No. Okay, let's take it from the top. So we're essentially doing a length check. Right, because length check doesn't really do jack squat. I mean, every doesn't really do jack squat. It just returns true or false. So instead of length check, we first of all need to do story words so that the original story gets replaced. And second of all, I guess then it should work. Return I guess then if statement should work. So if word dot length is greater than 10, we return stunning. No, we don't return anything. We simply do word equals no. It still doesn't work with every, because, like I said multiple times to myself before, every, where is it? Tests whether all elements in the array pass the test implemented by the provided function, and it returns a Boolean value. It doesn't return jack squat. So instead of every, we should use map. Right? Entries assign. Assign. Copies all. No, not assign. Let's go back to map. Creates a new array populated with the results of calling a provided function on every element in the calling array. I'm already forgetting. I'm feeling the knowledge slip out of my brain. You did it here, you numbnuts. So just do the same thing here. Okay, return if word dot length is greater than 10, ternary expression. Instead of that, return stunning. Otherwise, return the word. Boom, done. Okay. I will remember this for about 5 minutes and forget it again later. Let's move on. JavaScript arrays. Some documentation. Skip that for now. Thinking about errors in your code differently. Let's take a look at what do we have here in terms of our syllabus here. Syllabus. Well, we have a couple of more challenges. Actually, we might be able to finish JavaScript syntax part 2 today. Okay. This article explains how errors in your code aren't a bad thing, but rather an opportunity to learn. Additionally, it provides several steps to identify and fix these errors. When you get started with coding, it's inevitable that bugs will show up in your code. You'll get unintended behaviors, or you even get a long, possibly scary-looking error alongside your bugs. Even when you're a seasoned coder, you'll continue to encounter bugs and errors. That's a good thing. It's important to understand that making and debugging errors is part of the process, and you won't always know the solution right away. In this article, you'll learn how to find the bug that's causing your error and how to think about debugging process differently. Red is a beautiful color. Yes, it is. Red can be a dangerous color. Stop, danger, do not enter. All loud red signs tell us to turn around, don't go in there, you'll get hurt. It's easy to carry this mindset over to coding that many new programmers get discouraged and distraught over the red error messages that appear in the terminal. They think, oh no, I've done something wrong again. And clearly coding isn't for me, even the computer knows. But that's the wrong way to think of it. All programmers, even the most experienced ones, get errors all the time. Believe it or not, experienced programmers likely face far more errors than a new programmer ever will. Errors in your code mean you're trying to do something cool. Alright, consider the totally made up graph below. So number of errors you'll encounter, complexity of your code. As your code increases in complexity, the number of errors you'll encounter rises at a similar rate. An error means you're trying to do something that might be a little complicated, or very complicated, and it doesn't quite work yet. But by no means it is a sign that you should stop trying. In fact, there are entire engineering roles built around finding and fixing errors. A site reliability engineer finds and reports errors in web platforms. A test engineer builds automated tests to discover errors in software and makes sure that it meets the company's standards. Almost all major technology companies offer cash rewards to intrepid programmers who can find bugs in their software. Google, Amazon, and Microsoft all encourage users to seek out bugs and report any they might find. Why do they do this? Why would a major tech company want its users to try and break its software? Because they understand that encouraging bugs is one of the best ways you can improve your code. Bugs show you where the weaknesses are, make you really consider what you want your code to accomplish, and then guide you towards building more reliable and secure products. Okay, that makes sense. Error messages shouldn't be scary, but tackling them and coming up with solutions is still a skill that must be developed. Being willing to tackle an error is a great first step, and having some tools at your disposal to debug is a great way to feel comfortable tackling even the gnarliest of bugs in the future. So let's outline a few steps you can take to solve any compiler errors that you might encounter. These type of errors print out to the console. So, the following steps will guide you through a standard error that might get thrown your way as you learn to code, and they'll show you that errors aren't as scary as they seem. In fact, the steps are mostly a combination of reading the error carefully and copy and pasting it into the web search. Holy crap. Am I supposed to be copy pasting stuff? When an error first appears on your screen, find the line in the error specific to your code. Lots of error messages have tons of boilerplate details that aren't important to the actual error. You want to find the part of the error message that gives you insight about what happened. The line is generally at the top of the error stack trace. Let's take a look at a plausible error that you can encounter when writing a program that finds students on the honor roll amongst the list of students based on their GPA. Given the list, you might want to filter for all the honor students by looking at their GPA property. However, after running that code, a stack trace that contains a lot of error information will appear. So student.filter is not a function. Filter right, because we are trying to call filter, which is a array method on an object. So which line has the most important information? First two lines seem pretty promising. The first line says the JavaScript engine doesn't think that filter is a function, but it should be. So there might be an issue in how it's being used. The second line points to the line of code that is throwing the error, which is line 21, and that at its 26th character, the code is calling filter on students variable. Checking back into the code, you see that students is an object. This seems like a good place to start. Okay. Ask yourself, is the solution in the error? Often you'll encounter syntax errors that will show exactly where the error occurred and what the error was. When you get these types of errors, you can go directly back to your code and fix them. Here's an example of code that will throw a syntax error. Unexpected token. Well, the compiler is pointing to the syntax issue with the up arrow symbol, which sometimes makes it easier to debug. However, the issue is that there's accidentally a comma instead of a semicolon. All right. Error messages can help, but you still need to use your developer knowledge to fix the error. So, sometimes step 2 will not apply, and you'll have to dive a little deeper into the error. So let's return to the all honor roll error that comes up in step 1. Since the solution isn't immediately obvious, you'll need to do some research to understand why it flagged an error. Copy and paste the important part of the error message into the search engine and look through the results until you find someone else who has also run into that issue. To get better search results, you can include relevant keywords and modify the error message to be more generic. If the error message, type error, student's filter is not a function, it's highly unlikely that someone else is having a filter issue on a student's variable with the same data types. So that's the type of thing that could be more generic. So instead of searching for type error students.filter is not a function, you can try something like type error object filter is not a function and add a keyword for the language. So the final search result might be type error filter is not a function, JavaScript. After searching, one of the first results looks promising. Filter is a method on arrays. Since the code you posted contains an object, you're seeing this error. You may want to apply the filter after blah 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 blah. If you consult the filter documentation, you can confirm that filter is only for arrays. On the Stack Overflow page, it recommends using object.keys to turn the object into an iterable array. So you can use the filter array method on the new array. All right. So often you will not find someone who's trying to do the exact same thing you were trying to do, but who still encountered the same error. Read through their code a bit and see if it is comparable to yours. Even if the code is wildly different, the 1 or 2 lines that threw the error might be very similar to your code, so the solution may end up being the same. Okay. So tweak your code a little bit to match your use case and try it out. Worst case is that the error doesn't go away and then you can try again. Best case that it's fixed and you've learned what was causing the error. Every solution you implement is a new tool you can add to your programmer's toolbox. And another error you will know how to solve in the future. Thankfully, 31Pi's solution was able to solve the issue using the object values method. Take a look at the updated code. Yes. Okay, so after reading the documentation and a few more Stack Overflow responses, it also seemed like a good idea to try changing my code in a different way by making the student's object be an array instead of an object in the first place. That way the filter method can be used directly on the array instead of first turning an object into an array. Okay, so if it doesn't work, repeat steps 2 to 4. Keep searching through Google and Stack Overflow. The answer will be there. Sometimes it's helpful to Google parts of the error message, use console log to see the outputs, or to read about methods and data types at the website. The solutions to your errors are out there, and the process of finding them will make you stronger, make you a stronger and more confident programmer. As you grow and learn, expect to encounter countless errors, and expect each one to be its unique learning opportunity. Okay, maybe the answer isn't out there yet. There's a wealth of information out on the web, but you might be the first one to do something completely new and shiny. It's okay to ask for help. On the same sites and forums that you found help from, post a question. Ideally, you supply all the background information and provide relevant code that others can look at and do their best to help you out. Alright, so here we have error. Instrument is not defined. So we're looking at instrument, and the instrument is what? Function set instrument. Instrument is a local variable. Right, so okay, I would just move the console log. Just move the console log instrument inside the function body. Running the code results in instrument since the instrument is not a generic variable. You can search for something more generic, like blah 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 blah. When searching with the phrase reference error x not defined JavaScript, one answer is from a Mozilla documentation page. In the docs, it explains that the error appears if the variable is not available in the current scope. The solution moves the variable to the global scope instead of the function scope. So we can try that out. Well, that's possible too. Or you can move the console log inside the function body. My solution's better. All right. So, debugging. Before we jump into that, let's take one last break of the day and we'll get back to it after it. So, I'll see you guys in 10. And we are back. Let's jump in and let's finish this day. Thor is again laying directly under the camera. It's like he doesn't want to be filmed. And I can't really move the camera. Oh, there we go. There's Thor. Alright, any programmer will tell you that it is incredibly common to be making great progress working through a coding problem, then all of a sudden an error like this gets thrown at you. Type error. Capitalize is not a function. Alternatively, you might have finally finished implementing a complex function only to find it doesn't work at all as you expected. Okay, if any of these things happen to you, don't fret. In our article, thinking about errors differently in your code, you discovered that these experiences are normal for all developers, no matter how experienced they are. A key skill developers possess is knowing how to debug their code when issues occur. This lesson will build on that article, demonstrating how to implement those skills in real-life JavaScript situations. If you haven't had a chance to read the article yet, we highly encourage you to do so. Alright, let's go. So, error stack traces. We'll start this lesson by taking a closer look at the most straightforward way to know your code isn't working as expected. Errors. You might recognize errors as the scary red text that appears on your screen when you try to run broken code. A piece of software called a compiler is trying to translate your code so that your computer can understand and run it. However, the compiler is coming across a piece of code that it can't interpret. As a result, it throws an error back to you to let you know that it has to stop and why. The information is logged as an error stack trace, a printed message containing information about where the error occurred, what type of error was thrown, and a description of the error. Take a look at the diagram to the right to see where you can find all of this information. As a new programmer, it's easy to see an error and be overcome with a sense of dread and self-doubt. However, you'll soon realize errors are the best kind of bug you can hope for, since they tell you exactly what went wrong and where. And don't we know it? So, error location, right, file number and line, error type, error message. Straightforward, we already know that. Let's move on. Reading error stack traces. Now that we know what information we can get from the error stack trace, let's take a look at an example. So we have my variable is not defined. Using this stack trace, let's answer 3 questions you should ask yourself every time you want to debug an error. In what line did the error occur? Well, line 5. And line 1 here. What type of error? Here. And what is the error message? Here. Okay, so here we have near the beginning of the text file in the code editor, you will find an example stack trace. On line 14 of the text file, fill in the name of the file throwing the error in the stack trace. If you're unsure how to fill in the answer, feel free to check out the hint. So from what file? So this is the file. Just need to be able to copy it. Or do we just do this? Yeah. So on what line? Line 5. What type of error? Got a syntax error. And description, unexpected token. There we go. Easy peasy. Error types. So yeah, those are, I suppose this is pretty straightforward stuff, and it's the same thing as Python. So we have syntax errors, which is just typos, reference errors, when it's trying to reference a variable that does not exist or is not properly declared, and we have type errors. Well, I would sort of attribute all of these to sort of syntactical errors, I suppose. Type error, yeah. If you try to perform an operation on a value of the wrong type. Okay, so what type of error will be thrown on the line above? Syntax? Wait. Oh, right. Reference. Right. This one will be... So we have a string. But that's not a string, so this will be a type error. And this will be a syntax error. Right. Debugging errors. So here's a process for efficiently working through your code's errors one by one. Run your code using the first error stack trace. Identify the error type, description, and location. Go to the file name and line number indicated by the error stack trace. Using the error type and description, identify the bug in your code. Fix the bug and rerun your code. Repeat steps 1, 2, 3 until your code no longer throws any errors. Alright, so what are we getting? We're getting syntax error, unexpected token in line 1. So, function. Right, we're supposed to close this. Then we have error in line 4. Total. Still in line 4, but this time we have a reference error, number sum. Oh, that does not exist. So it's supposed to be just sum. There we go. Everything works. Silent bugs. Errors thrown by the computer are really useful because they identify the bug type and location for you right away. However, even if your code runs error-free, it is not necessarily bug-free. You may find that your code is consistently returning incorrect values without throwing any errors. A lack of thrown errors does not mean your code logic is completely correct. Don't we know it? An incredibly powerful tool for locating bugs is a method you likely learned very early on in your JavaScript journey, console log. By adding a print statement to your code, we can identify where things went wrong. Let's try using console log to do some debugging. Sure thing. So that is supposed to be taking a string containing a single word as an argument and return the capitalized version of that word. If the string contains multiple words, it should return null. Okay, currently the code is not working as expected. Take a look at our tests on line 16 and 19. So should return hey, should return null. Okay, let's use console log to debug this code. Start by adding console log statement to line 2. Console log, and we are checking the word. Hey ho. Alright, looking at the console output, both hey ho are being printed as we expect. No bugs yet. So now, comment out the console log statement from the beginning of the function. Then add the following console log statement inside the if statement to see if it's working properly. Sure. So, capitalize a single word. A returns null. But hey ho returns hey ho. Ah. Look at the console output. Hey is being printed from inside the if statement. And hey ho is not. This is the opposite behavior we expected. Right, so as I expected, just remove that and we should be fine. Yep. All right, let's move on. Debugging with console log. Let's synthesize our workflow from the previous exercise into a reusable set of debugging steps. Go to the beginning of the malfunctioning code. Print out all the starting variables, existing values, and arguments using console log. If the values are what you expect, move on to the next piece of logic in the code. If not, you have identified a bug and should skip to step 3. After the next piece of logic in your code, add console log statements. Add console log statements to ensure updated variables have the values that you now expect and that the block of code is being executed. If that logic is executing properly, continue repeating the step until you find a line of not working as expected. Then move to step 3. Find the identified bug, blah, 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 blah. All right, so in the code editor, we have included a broken function for you to debug. This function is supposed to take 2 strings, compare the first letter of each, and return the string which comes later alphabetically. If the first letters of both strings are the same, it should return null. At the bottom of the file, we've included 3 test cases and their expected outputs. If you run the code, you will see that they are not working as expected. Using console log, debugging mindset laid out above, walk through the code, locate 3 bugs we have included for you, and fix them. Alright, so let's see. First of all, we have a function. I have 2 variables. First letter passing into strings. So the first letter. So first of all, this should be 0 and 0, right? So avocado and blueberry returns avocado. Zebra and aardvark returns aardvark. And astro and far returns null. So that's fine. Technically it works. So then return null if first letter is higher than the first letter 2. Wait. Oh, later in the alphabet. So this should be so. So blueberry, zebra, and null. So that's 2 bugs. What's the third bug? Oh, I guess this counts as this counts as 2 bugs. Okay, let's keep going. Sometimes once you've tracked down a bug, you might still be confused on how to fix it. Whenever you want to know more about how JavaScript works and what can it do, the best place to go is documentation. You can find the JavaScript documentation at MDN JavaScript Web Docs. The MDN JavaScript Web Docs are a powerful resource, but they can be overwhelming because they cover so much information. We encourage you to explore the docs, but often the fastest way to access a specific part of the docs that you're interested in is to Google it. For example, if we wanted more information on the number objects is nan method, we could Google MDN is nan and then click the link to the MDN page. If we're looking to see a list of all the string built-in methods, blah 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 blah. Okay, I don't need a tutorial on how to Google things. So we included a function that is supposed to take a string and return a version of that string repeatedly twice. For example, you can see the test case at the bottom of the file. We expect double string echo to return echo echo. However, currently, when we run our file, nothing happens. Clearly, we are using the repeat method incorrectly. Now let's take a look at the repeat method. Repeat. So represents a repeated fragment of the track list, allowing a large number of columns or rows that exhibit a recurrent pattern to be written in a more compact form. So the first argument specifies the number of times that the track list should be repeated. And the second argument specifies the set of tracks that will be repeated. Okay, so in this case, we just do repeat 2 and echo, or just string. Yep. What? Is that not the same website? Should be. What are you talking about? That's what it is. Oh. It's an older website, probably. Older version. And we probably don't need this as well. Now that we found the documentation for the string, let's read the documentation to see what we're doing. Take a look at the parameters section of the document. Can we see blah 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 blah? Works. Let's go. Stack Overflow. We've included an unfinished function. Contains cake. It takes a string and checks if that string contains a substring cake inside of it. If so, it should return true. If not, it should return false. Using the information in this Stack Overflow post, implement the functionality of this function. Alright, let's take a look. I like how it takes us to Stack Overflow and stuff. Close up all of these tabs, to be honest. Don't really need them. So, how to check whether a string contains a substring in JavaScript. Includes is case sensitive and is not supported by Internet Explorer without a polyfill. Use in the older versions use index of, which returns -1 when a substring cannot be found. Right. So what are we doing here? Implement the functionality of this function. Oh, we're just supposed to return. Okay, return. Wait. Returns whether or not the provided string contains a substring of cake in it. Oh, okay, let's do, well, I can think of a couple of ways to do it. But let's see if it works with if we just copy paste it. No. Okay, let's do it simpler. Return string dot contains cake Wait. We're passing in a string. Oh, yeah, okay. Return string contains cake. If it does, true. Or contains is not a function. Excuse me. Pretty sure it is. Wait. Here. The includes method of string values performs a case-sensitive search to determine whether a given string may be found within the string. Oh, includes, not contains. Great. There we go. Okay. Wow, this is... Oh, we just run it. Oh my god. We have provided you a broken implementation of a function called isStringPerfectLength. This function takes a string, a minimum string length, and a maximum string length. It should return whether the provided string is within the range of the two lengths. More specifically, if it is longer than the min length and shorter than max length. Provided 3 example test cases. Okay, so let's see. We have to debug this, probably. So we have unexpected token on length, because we didn't close these. Then we have string length not defined. String length. And then we have problem in line 6. String length. Right. If string length is return false. String length is less than max length. No, it should be if string length is string length min length. If the string length is so wait, we're returning true. Takes a string, minimum value, maximum value. It should return whether the provided string is within the range. Okay, so if string length is higher than minimum length, it returns false. Oh, it should be less. And this should be more. That took me way too long. I was like, what is going on? There we go. Pair programming. Let's take a look. It just seems like one article. All right. As part of this career path, you will have the opportunity to connect with other learners to practice and apply your skills. At this point in the path, you are ready for pair programming. Throughout the career path, we will prompt you at specific intervals to work with peers, but you should feel free to pair program as often as you like. So, learn about in the article, find someone to pair with, meet with your partner. Ah, I'm good. Oh, door has moved to his bed. All right, so intermediate JavaScript, code challenge. In the exercises that follow, you will practice and reinforce your understanding of JavaScript, scope, arrays, loops, iterators, and objects. Oh, so the entire second part of JavaScript. Okay, let's take a look. Reverse array. Write a function reverse array that takes in an array as an argument and returns a new array with the elements in the reverse order. Okay, there's an array method called reverse that does a lot of this for you, but you're not allowed to use it here. Okay, well, sure, let's do it. So we need a function, right? So reverse array. This function will take in an array, and it needs to, take in an array, and it needs to do what? Well, we can return array dot what? No. Let's have a new array. Right? And then inside this function, we can have, wait a second, gotta go back to my cheat sheet. I think we can do like map function on this thing, but I just need a refresher on how syntax looks like. Where is it? Iterators? Yeah, I think so. Or we could do for each. Guess it doesn't matter. Okay, so we just do array dot for each item in the array. We simply do, oh, here, new array, new array. So new array dot push item, and then eventually we just return and here we return new array, right? I think that's correct. All right, let's uncomment this. And wait, returns a new array. I mean, it should work. With the elements of the array. in reverse order. Wait, pushing appends it to the end. Oh, so we need not push. We need... What's the one that adds to the beginning? What was it? Entries. Push. Shift. Unshift. Right. There we go. Should print. Oh. Wait. There we go. Yeah. Okay, fairly simple. Greet aliens. Write a function greet aliens that takes in an array of strings and uses a for loop to print a greeting with each string in the array. The greeting should take the following format. Oh, powerful string element, we humans offer our conditional surrender. Sure. So we're writing a function again. So, greet aliens. We take in the array. And then for let's try to remember the for loop syntax. So for let item of array, right? We want to console log basically this. And instead of string element, we add item. Yeah. Cool beans. I'm glad I'm remembering these so easily. This usually takes me a little bit longer to apply the concepts that I learn here. Right, write a function, convert to baby, that takes in an array as argument and using a loop returns a new array with each string in the array prepended with baby. Baby, 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 baby. Okay, so essentially it is a variation to our for each thingy. We can have a const, let's say, convert to baby. I really like these exercises that give you a little bit more freedom to your variable naming conventions and whatnot. So we take in an array, and then we do what? Wait, I'm like losing my train of thought suddenly. All right, so we're gonna need a new array. So, new array equals this. So then for, well, we don't need a for loop, to be honest. But I guess they're asking us to do it with a loop. Sure. For let animal of array. We do what? We do new array dot push baby animal, like so. No. Oh, we didn't return anything. And then we return new array. Yep. So if we uncomment this, yup, baby human. Should be human baby. Okay, let's check the next one. Fix the broken code. We wrote a function smallest power of 2, which should take in an array and return the lowest power of 2 that is greater than or equal to each number in that array. Oh my god, math! Why you gotta do me like that? A power of 2 is any value to the power of 2, where n is a non-negative integer, including 0. The list of powers of 2 for non-negative integers start with 1 blah 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 blah. For example, if the array were 6 to 1150, then the smallest power of 2 function should return the following array, 8 to 16 and 64. Okay, so within our smallest power of 2 function, we create a new array called results. We then loop through the array and calculate the smallest power of 2, which is greater than or equal to the current element before using push to add it to the results. It's not doing what we want. Can you fix our code, please? Sure. So we're getting back just 8. So let's take a look. First of all, probably I would put this into parentheses. It's still not working. So that's the result. We're doing a for loop. I equals 0 while I is less than the length of the array. I plus plus. So the for loop is initiated correctly. Number equals our array I. Okay. So then it sets it to 1. So while I is less than number, which is smaller, I equals I times 2. And then we push it. Okay, so the problem is with the second iteration, within the second iteration, because here we are reassigning the I here. I think it should be moved over here. Ooh. Infinite loop. Never mind. So no, it shouldn't be moved over there. Still getting 8, right? Yeah. Searches for the smallest of 2 greater than the given number. While I is less than number, but number is being set as the index of the array. So while we're running through this, let's say the first time around, I is 0. So we pick up the first number. So if the first number is, or if 1 is less than the number, which it is, then 1 times 2. Oh, 1 times 2 equals 2. So we push 2 in the results. Then we check again. Is 2 less than 5? It is. Oh, but the problem is... Oh, the problem is it's being pushed before the... Oh, but we're looking for the smallest power of 2. Greater than the given number. Oh no, it did okay. Because it pushed 8. But then it... Okay, then it increments I by 1. And it picks number 3. So we come back here. I gets reset to 1. So while I is less than the number, and it is, we... I... 1 times 2 is gets put to 2. Check it again. 2 is less than 3. So 2 times 2 equals 4. And 4 is not less than 3, so it should be pushed. But why isn't it? Ah. Because as it jumps out of the while loop, it should add it. Let's just try console log I 8. Okay, so right, it only reaches this place once for some reason. What's happening with I? Here. Wait, no, here. Let's do both sides. Console log I. And do the same thing afterwards. So 1 and then 2. 2 and 4, 4 and 8. That's fine. And it doesn't go back for some reason. But why? Okay. Let's console log number. Five. Results. Push I. Just jumps out of the loop. Okay, what if we type in continue? No. Break? No. Something is off. Something is off. Something is off. Is this an indentation problem? I can't tell. Thor, can you help me? Can you help me solve this problem? Number array. Okay, so this for loop wait a second. That's the problem. Because we're using the same conditional. Or we're using the same variable as here. Which we should not do. Let's do A. There we go. Yep. That was the problem. Okay. We will leave the rest of these exercises for tomorrow because it's time for us to end the stream. We did quite a bit today, I feel like. We are roughly 20% done with our... one second. Wait, what is happening? Where's my... 1 second. There we go. All kinds of technical difficulties today. But nothing we can't get through. Ugh. Right, let's take a look. Let's take a look. What did we do today? So we finished objects, we did iterators, we did errors and